Hello guys, welcome back to Maison African Motives, still on Mathematics N4. In this platform, we've got questions that we're going to work on pertaining the Cramer's rule, the application of determinants, complex numbers, this and that. So that's question number 4 from the August 2021 question paper. So the first part we are given on question 4, we shall quickly rush through the questions that we have. So you're given though that's equations, simultaneous equations, then determine on 4.11 the determinant of coefficients, okay? Expanding along the first column. So you're told to expand along the first column, which is the most important part that we have in this case. Take note, guys, columns, these are lines like this, these are columns, and thus these are rows, okay? So if we are to expand from the first column, this is the first column where we are referring to these numbers here. So that's your first column. So in order for you to have the determinant, we can rewrite this in a determinant form. That is, we are going to have the coefficient of A here, which is 1. So this is going to be 1, 2, minus 2. Then here on 2, that's 2, 3, and B here it's a negative 3. All right, then we move on to C, which is 3, negative 2. C here, which is negative 1, the coefficient. So remember the presentation of this is the way that you are used to. Okay, so they are saying find the determinant by expanding the first column. In this case, this is our first column. So we know that we have got two methods that we can use to find the determinant. But as for me, I love to use this one for using the signs direct. That's a plus, a minus, and a plus. If you take as a row, it's a plus, minus, a plus. That's a row. But here we are talking of a column. All right. So we are given, we take note, if you are to find the determinant, we know that the determinant in this case is going to be equivalent to, we start with a positive, a 1 here, affected by the sign. So 1 is affected by a plus, so that's a 1. Then you find the determinant for that one if you close the row and the column where we have got 1. So already we have closed the column here, we close this row here. All right. So if you close this row, guys, you're going to see that you're going to remain with the 3, minus 2, minus 3. So these are the numbers that you're going to take. So you remain with 3, negative 2, negative 3, negative 1, okay? We move on to 2. So 2 is affected by a minus. So it's minus times 2, which is minus 2. You find the determinant which corresponds with minus 2 after closing the row and the column where we have minus 2. So this part is no longer working. This one, we have used this part. All right, so this time we are going to close the row and the column where we have got 2. Already the column is closed here. So all you need is to close the row here. So you've closed the column and the row. So you remain with 2, 3, minus 3, and so forth. So those are the numbers. That's 2, 3, negative 3, and negative 1. So you write these numbers in a determinant form. You move on to minus 2, the last part. So it's minus 2 versus a plus. So plus and the minus, that's a minus. So it's going to be minus 2. Determinant of this time, we are going to close the row and the column for minus 2. All right. So this part is no longer working, this part that we had before. So we are working with the minus 2. So already the column is closed. Close the row, you remain with the 2 by 2 matrix of 2, 3, 3, and minus 2. So these are the numbers that you're going to use. That's 2, 3, 3, and minus 2. All right. So our determinant, as we know that the determinant is the product of the major diagonal minus the product of the minor diagonal where we've got 2 and what? Minus 2 and minus 3. So that is going to be the product of 3 times minus 1, okay, which is you multiply whatever that you're going to get. So this is negative 3 minus the product of the minor diagonal, negative 2 and negative 3, which is a negative, which is going to be 6. So it's going to be minus 6. Then we've got minus 2. We do the same thing. Our major diagonal here, that's 2 and minus 1. So 2 times minus 1, that's minus 2. Minus, we move on here, is 3 times minus. So it's 3 times minus 3, which is minus 9. So minus and minus, that's a positive. So it's going to be plus 9. Minus 2 into the major diagonal here is 2 and minus 2, which is negative 4. 3 times minus 3, which is 9. Then we subtract, remember, major diagonal minus the minor diagonal. Okay, so if you simplify this, we are going to obtain negative 9 here, minus 3, minus 6, that's minus 1, that's minus 9 times 1, which is minus 9. Then we've got negative 2 plus 9, which is 7. Then 7 times minus 2, that's negative 14. All right. So we are going to have, sorry, let's put this one. So this is going to be negative 14. All right. Then we move on here. That's negative 4, negative 9, which is negative 13. So if we multiply here, this is going to be a positive 26. Negative by negative, that's a positive, which is positive 26. All right, combine the numbers. We are going to obtain a 3. That's negative 23 plus 26, which is a positive 3. So that is the determinant that you're going to have in this case. All right, on 4.12, write down and evaluate the minor of negative 1. So we know that the minor is found by closing the row and the column where we have minus 1. Okay, so that is going to be the minor. So we have to close the row and column where we have minus 1. So this is what we have from this part. Okay, so where do we have minus 1? Let's just remove this part first. Then we can try and see. Okay, I just hope it's clear there. All right, so remember, this was the format that we had before. This one does not work at all for now if you're dealing with a minor. So a minor is just a determinant that you find by closing the row and the column where we have minus. This is minus 1. So we close the row for minus 1. We also close the row where we have minus 1 like this. So we remain with 1, 2, 2, 3. So this is what we are going to have, 1, 2, 2, 3. So find the determinant just like what we did there. Major diagonal, that's 1 and 3. So 1 times 3, that's 3 minus the product of the minor diagonal, which is 2 times 2, that's 4. So 3 minus 4, that is negative 1. So that's a minor. So like I said, if you are actually dealing with a minor in this case, you are given a consideration that you have got a minor. You work with the determinant as it is. You do not have a condition where you are going to multiply by a sign of this. No, you work with the determinant as it is. Okay. 4.13, we are now given to write down and evaluate the cofactor of minus 3. Okay. So a cofactor is a signed minor. Whenever you are given to find a cofactor, it's a signed minor. All right. So thus you calculate the minor, then you multiply it by the corresponding sign. Okay, we are referring to minus 3. Let me show you how these signs are going to affect. Okay, so at minus 3, sorry for that. I need to just reuse this. Okay. So this is what you're going to do, guys. Let's just remove this part. All right. From that part that we used to calculate the determinant, remember, I used the signs there. It was supposed to be like this, okay? This is our minus 3. We have got a matrix which corresponds to this, but it has got the sign. So it's plus, followed by minus, a plus, and so on. After plus, it's minus, plus, minus, plus, minus, plus. It must be a 3 by 3 matrix, just like this. So here we are referring to minus 3. So minus 3 here corresponds with a minus here. That's the sign So when I'm saying a cofactor, it's a signed minor. I'm saying the number, when you close for 3, this is your 3, you close the row where we've got -3 here, and the column where we've got -3. But the determinant that you obtain, it must be multiplied by the corresponding sign, which is a minus. So that's why I'm saying here that a cofactor is a signed minor. It's a minor which is being multiplied by the corresponding sign. So -3 is going to be affected. We say the sign there, it's minus. Then we find the determinant where we have closed the row and the column where we have -3. So we saw that if we close -3, the row and column will remain with 1, 3, 2, and -2. So those are the numbers that you're going to remain with: 1, 2, 1, 3, 2, and -2. All right. So these are the numbers. We said 1, 3, 2, and -2. So find the determinant. Then after that, don't forget the sign. So it's 1 and -2, the major diagonal, it's 1 and -2. So 1 times -2, that's -2 minus, the minor diagonal is 3 and 2. So 3 times 2, that's 6. So it's going to be negative into -2, -6, which is -8. And our answer is going to be a +8. So that's a cofactor. It's a signed minor or a cofactor, okay? So that's what you're going to have. We move on to 4.2. So on 4.2, we are given a complex number Z, all right? And from the complex number Z, we are given, write down the conjugate of Z. So guys, the conjugate of Z written as Z bar is simply introducing a minus in the imaginary part. So we are given J as the imaginary part. So if we introduce a minus here, it becomes a positive. So that's -2 plus J square root of 6. That's the conjugate, okay? Simply introduce a negative on the imaginary part. Then on 4.22, we are now given to determine the modulus of Z. Take note, not Z bar, the conjugate, no. Of Z, we are back to the normal Z, this one that we are given here. So what is the modulus? So we know that the modulus is the resultant of the two. So the modulus of Z is supposed to be the square root of A squared plus B squared, which is equivalent. This is our A and that's our B. So it is going to be the square root of -2 squared plus, okay, we are given here, this is square root of 6 with a negative. So it's negative square root of 6 in bracket like this squared. All right. So if you simplify this properly from your calculator, you are going to obtain the square root of 10. All right. So that is the modulus. Then on 4.23, determine the argument of Z and convert it to polar form. So we need the argument of Z. So take note, for us to have the exact value for the argument of Z, we are supposed to have this indication on an Argand diagram. Okay, so I'm just going to represent this. You're going to understand what I'm trying to say here. Remember that we are given that our Z is equivalent to -2 negative J square root of 6 like this. Okay. So if we are to find the argument, remember the argument is the angle. Remember in polar form, Z is given by R angle of theta like this, or R cis theta. All right, so we've got R cis theta. So R is the resultant, which is the modulus. Then theta is the argument. All right. So this theta now, in order for you to find the exact value, it's best for you to know where these values are going to lie, in which quadrant are we going to have these values. Okay, so this is what you're going to have. That was question 4.23. Okay, if I'm not mistaken, that's 4.23. So representing on the Argand diagram, we can see that the real part, it's a negative. This is our real part, and this is the imaginary part. Real is negative, imaginary is negative. Which quadrant do we use where the real axis is a negative and the imaginary is a negative? Which quadrant is that? That is the third quadrant, where we are going to have the real negative, imaginary negative. So we are going to have our answer, we are going to have something like this, -2, okay, let's just change here. So we are going to have something like -2, then negative j square root of 6. So let's just write square root of 6. Because imaginary, we are already saying there is a j there in the imaginary. So what is important is to know that this is where our minus square root of 6 is. So the resultant taken from the point of intersection to where these two meet, -2 and minus square root of 6, maybe they meet at a certain point here. Let's just say something like this. So we are supposed to join this to the intersection of these two. That is what we are supposed to have, something like this. Okay, so this is where we are given our z, guys. What I want you to know what is happening here. From the diagram that we have, the theta that we are referring here, the one that we are supposed to calculate, this theta, is the angle that is being taken from the positive real axis. All right, so we're going to take this angle from the positive real axis. It's either in an anti-clockwise direction or clockwise, but it's taken from the positive real axis. So this is the theta that we are referring to, or it can be taken in a clockwise direction. But you must know that if you take in a clockwise direction, this is going to be a negative. If you take in an anti-clockwise direction, the angle is going to be a positive. All right. So you can't calculate this theta direct. So the diagram is going to help you to calculate the angle inside the triangle here, which in this case, I am going to refer to as alpha, not theta. All right. Why having two angles? Because this is not a, if you are to check, it's a right angle triangle that we have. So utilizing the angle that is inside this triangle, if we can find alpha, then we can find theta, because we can relate either from 180 or from 360. So that is the most important part of having your diagram. Yes, if you just know this, just to visualize this when you are calculating your theta is very, very important, because most of you, you leave your answer somewhere where it is not supposed to be like. Okay, anyways, so what I'm saying is you are supposed to calculate the alpha first. So according to this triangle, we can see from the sides, remember we said this is minus square root of 6, the whole of this side. So it means this is where we have our minus square root of 6, the whole of this side. This point is -2, so it means from this point to this point, that's a -2. So we know that from our alpha, this is opposite and that's adjacent. So which means we are dealing with tan. So alpha is equivalent to arctan, opposite over the adjacent. Remember the trig ratio for tan from your soccer tour, that's soccer tour. Okay, tan is opposite over adjacent. So if you want the angle, it will be arctan. So that's arctan opposite, which is negative the square root of 6 over the adjacent, which is -2. All right, so if you have to simplify this from your calculator, you must obtain something like 15,768 degrees. Okay, that's the alpha that you're obtaining. So the alpha is this angle in between. So if you say this is your theta, now this is wrong. Alpha is the angle inside the triangle. And most of you, you leave your answer at this point, which is wrong. So for you to have the theta, it depends now with which theta are you using. Are you using the negative one or are you using the positive one? So in this case, I'm going to take the positive theta. So if we are to take our theta, which is supposed to be a positive, we are referring to this angle here, that is the one that is a positive. How are we going to have the whole of this angle is in the third quadrant, where we know in the third quadrant, theta is equal to 180 plus, because we've got what? A straight line. So it's 180 plus alpha. So our theta is going to be 180 degrees plus alpha now, which is theta is 180 plus alpha, which is 50,768 degrees. This is the most important part. So if we add these two, we must obtain something like 230,768 degrees. Okay, so that's our theta. all right, which is the argument, all right? So theta representing the argument. But that is not only what you are asked to do in this case, all right? Let's see. It was actually on top there. Okay, the question is further saying, and convert it to polar form. So in polar form, like I was saying, our polar form is supposed to be in this way, where z is equal to r angle of theta or r cis theta. So that means we are going to have, in this case, our z. Okay, we can even take our answer here. All right, so therefore, our z in this case is going to be r angle of theta, where r is the modulus. The modulus we obtained here, it was square root of 10. That was the modulus r here, which is square root of 10. So we are going to have this as the square root of 10 angle of theta, which is the angle of 230,768 degrees. Okay, or you can write this as r cis theta like this, where z is equal to r, which is square root of 10, then it's cis theta, where our theta is 230,768, or some can write as square root of 10 cos this plus square root of 10 j sine. Guys, it's so many ways of representing this. So like I said, it was either you're working with a positive or a negative angle. Okay, so that was our z in the polar form after finding the argument and the given resultant, which was the modulus. Okay, let's check the other part of the question. All right, that's supposed to be on the next page. You've got a 10 over there, so let's turn over and see. All right, on the other part, we are now given represent z in an Argand diagram, complex plane, and indicate all values on it. Okay, so they are now saying indicate z in what? On the Argand diagram. So that's 4.24. So if you check here already, when you were calculating in polar form, if you cross-checked there, when we wanted to calculate this z in polar form, we already did or drawn the Argand diagram. So we already have the Argand diagram. So this is the diagram that you're going to just redraw. But now on your Argand diagram, you must indicate the theta now, because you have calculated your theta, and your theta here you obtained. Okay, so this is our theta. So our theta here we obtained 230,768. So this is the diagram that you are just going to redraw. Okay, do not indicate all these arrows. Okay, you just indicate one arrow now, the one that you used to have your theta, the positive or not the negative. So like here, I was just illustrating. So I want you to redraw this same diagram. That will be your answer there. All right, so let's check the other part of the question. On 4.3, we are now given to simplify j to the exponent of 19, and that is 2 marks. So j to the exponent of 19, whenever you're given this type of a question, always target j squared, because you know that j squared is equivalent to -1. So in this case, j to the exponent of 19 is same as j squared to the exponent of 18, which is the even number that we have, which is what? Which is 18. All right. Sorry for that. Not 18. Not 18, but it's supposed to be number before 18, number before 19, which is 18. But we must separate this 18 that we have. Okay. So 18, because of 2, it was supposed to be j to the exponent of 18 direct, guys. Okay. But we want to separate j to the exponent of 18 in terms of j squared. So this is going to be j squared. Then you divide, because you know that from your laws of exponents, x to the exponent of a to the exponent of b is same as x to the exponent of ab. So already you've got a number that is 2, but the actual number was supposed to be 18. So which number that you're going to multiply 2 times that number, you obtain 18. So that's a 9. You can just divide 18 by 2, which is 9. So which means this is to the exponent of 9. So 2 times 9, that's 18. But take note, this is not j to the exponent of 18, it's j to the exponent of 19. So we have used 18 of the j's now. So which means how many j's are going to remain? we are going to remain with 1j because there were 19, we used 18 here. So we are remaining with 1. All right, so from this part, we said j squared, it's minus 1. So this is going to give us minus 1 to the exponent of 9 times a j, where negative 1 to the exponent of a 9, that's a negative to the exponent of an odd number, it is going to be negative. So it's negative 1 times j, which is going to be negative j. And we can't simplify negative j. So that means our answer is going to remain like that. Okay, so that's what we had, guys, on this question, carrying a total of 20 marks. So please, guys, let's continue revising as much questions as we can. Also revising from our videos and YouTube, Facebook, from Maison African Motives, till we meet again.